Hello. That's working. Afternoon, everybody. Welcome to the great debate on geoengineering. I'm Casper Hewitt, and I'll be chairing this session. Before we start, I'd just like to thank my co-conveners. That's Jonathan Dick, Mark Wilkinson, Paul Quinn, Oksana Tarasova, and Barbara Ferreira for all their help in putting this session together. We've got a great lineup. We've got five speakers. I'm sure you're going to enjoy them. I'm going to do a minimal amount of talking, but actually so are they, because the idea is to give most of the time in this session over to you. So what we're going to have is very short presentations, just 5 minutes each. I'll then give the speakers just a couple of minutes each to come back on each other's introductions, but then about 40 minutes or so will be given over to questions and points from the floor. So while you're listening, prepare your questions and points. So I'd like to introduce our panel. On my far right, on your left, is Ken Caldeira. Since 2005, Ken's been a scientist at the Carnegie Institute for Sciences Department of Global Energy and a professor by courtesy in Stanford University's Department of Environmental Earth Systems Sciences. Prior to that, he was the Energy and Environment Directorate at Lawrence Livermore National Laboratory. His bachelor's degree is in philosophy from Rutgers College, and he has a master's and PhD in atmospheric sciences from New York University. Ken takes a wide-angle view on the world, investigating issues related to climate, carbon, and energy systems. His primary tools are climate and the carbon cycle models, and he also does fieldwork related to ocean acidification. His basic research strategy is to ride on the coattails of the excellent postdoctoral researchers in his group. And kind of you to say so, I must say, is it? Quite right. Next to him, we have Dr. Krishna Kumar Kanikachala. Dr. Kumar is a coordinating lead author in Working Group 1 of the 5th Assessment Report of the Intergovernmental Panel on Climate Change. I should just say IPCC, shouldn't I? It's easier. And has over 30 years of research experience in the areas of monsoon, climate change, and impact assessment. He has a doctoral degree in atmospheric physics from India and has been working with the Indian Institute of Tropical Meteorology in Pune, India since 1982, and now on an assignment with Qatar Meteorology Department as a meteorological consultant. He has published more than 50 research papers in peer-reviewed journals, won several awards, including the prestigious Norbert Gerbier-Mumm International Award of World Meteorological Organization. Have I pronounced that right? Yes. He's a fellow of the Indian Academy of Sciences. On my immediate left is Professor Dr. Mark Lawrence. Mark's a scientific director at the Institute for Advanced Sustainability Studies in Potsdam. He leads the Sustainable Interactions with the Atmosphere Research Cluster, which focuses on the impacts and mitigation of short-lived climate-forcing pollutants, particularly in the face of global urbanization, and on the potential impacts, uncertainties, and risks of climate engineering. Mark's co-author of over 100 peer-reviewed publications, has been editor for the Journals of Atmospheric Chemistry and Physics and Atmospheric Environment, and has served on various international committees, most notably the science team of the UNEP Atmospheric Brown Clouds Project, the Scientific Steering Committee of the International Global Atmospheric Chemistry Project, and the Commission on Atmospheric Chemistry and Global Pollution. In 2013, he became contributing author of the IPCC. In the middle there, we have Dr. Andreas Oschlis. Andreas is a professor of marine biochemical modeling at GeoMar and the University of Kiel in Germany. Having studied theoretical physics at Heidelberg and Cambridge, he moved into oceanography for a PhD in Kiel, awarded in 1994, and worked as postdoc in Toulouse as assistant professor in Kiel and professor in Southampton before moving back to Kiel in 2006. His research interests include the global carbon, nitrogen, and oxygen cycles, their sensitivities to climate change, and the development and quality assessment of numerical models appropriate to investigate these. He's PI of the Excellence Cluster, the Future Ocean, Speaker of the Collaborative Research Centre, Climate Biochemistry Interactions in the Tropical Ocean, and Coordinator of the Priority Programme, Climate Engineering, Risks, Challenges, Opportunities. Couldn't be more relevant to this debate, all funded by the German Research Foundation. On my far left, on your right, is Dr. Paul Quinn, who's one of the conveners of this session. Paul's a senior lecturer in catchment hydrology at Newcastle University in the UK. He's worked for 16 years in the School of Civil Engineering and Geosciences, and also with the Newcastle Institute for Sustainability, for research on sustainability. He describes himself as an Earth systems engineer specializing in catchment systems engineering. This includes pollution, flood and drought management. Basically, Paul likes to cover catchments in ponds, wetlands and woody debris, and believes in working with natural systems. He is optimistic that good, healthy systems just need good management. So we've got a great panel to take us through what they think about geoengineering. Geoengineering, of course, is quite a general term. It covers everything from simple things like reforestation through artificial trees and cloud seeding to the space age, putting mirrors in space. So it's a very general term. Hopefully we'll cover a little bit of all of those in the ongoing discussion. One of the things that I'm quite interested in is the whole idea of which and whether we take these technologies forwards. And that's the central question for this debate, hence the subtitle, The Way Forward. So without further ado, I'd like to hand over to Ken for your 5 minutes.
Hi, thank you very much. I'm really amazed at the turnout for this session, and I think it's interesting that there's such broad interest in this question. So I guess I'll start out by just saying that there are two broad classes of things that have been called geoengineering, and there's not necessarily consensus on nomenclature, but there's one area is greenhouse gas removal or carbon dioxide removal, and the other has been variously called solar geoengineering or solar radiation management or something like that. And these are two very different things. If we first talk about the carbon dioxide removal or greenhouse gas removal, the root cause of the climate change, or at least the cause of climate change and ocean acidification is carbon dioxide. And for this century, it's likely that that emissions from humans will be positive. And so carbon dioxide removal in that context can be thought of reducing net greenhouse gas emissions. And the primary issues that are really faced with the best carbon dioxide removal has to do with cost and local environmental impacts. In other words, if we could either plant forests or remove CO2 from the atmosphere and stuff it underground, and it was cheap and the local environmental impacts were acceptable, then I think we would want to go ahead and deploy it today. That the main issue is really cost and just local risk. That's not true of what I would call the worst carbon dioxide removal approaches. The worst, which I would include things like ocean fertilization in the sense that they involve trespassing on a global commons and converting natural systems into human managed systems and so on. And so while there are some carbon dioxide removal things that have governance and global environmental consequence issues, for the most part carbon dioxide removal approaches reduce climate risk and they don't introduce any new climate risk. In contrast, the solar geoengineering approaches, while there's some prospect of reducing amounts of climate change, they introduce new climate risk, new governance problems, and other forms of environmental and socio-political risk. The climate model simulations that have been done to date suggest that solar geoengineering approaches could potentially reduce climate change in terms of global temperature, regional and seasonal temperature fields by perhaps 90%, precipitation changes by perhaps 70%. So, there's always the potential or the almost certainty that climate models are wrong, at least in detail, and that unexpected things will happen environmentally. And for me, the bigger concern is what are the unexpected things that would happen sociopolitically in terms of, would that cause people to emit more CO2 and not work as hard on mitigation, or would it generate international conflict or these kinds of things? Why am I in favor of researching these things? And I would say in terms of carbon dioxide removal, of the best of them, I'm in favor of not only researching them, but of deploying them if they were cheap enough and the local environmental impacts were small enough. Solar geoengineering, even if you could show that they work perfectly and had minimal adverse environmental impact, I would probably oppose deploying them as long as we're still building devices with smokestacks and tailpipes, because if we're putting aerosols in the stratosphere at the same time we're building things with smokestacks and tailpipes in a way that this is just facilitating continued expansion of a polluting infrastructure, and that if it's enough of an emergency to deploy a solar geoengineering system, it's enough of an emergency to stop deploying devices, power plants, automobiles that make the problem worse. I just have a few seconds left. When would I think we might want to deploy a solar geoengineering system? To me, it has to be something like if there were massive famines with hundreds of millions of people dying and the global political system were too screwed up to deal with it through more reasonable ways of doing it. That if by emulating a volcano we could save hundreds of millions of lives, I think I could be in favor of it at that time. Thank you.
Thanks, Ken.
Yeah, good afternoon, and I want to clarify before I make my statement that what I say is not from IPCC. It is my personal views and personal expressions. And these are essentially, in fact, I'm thankful to Ken for giving a nice outline of what the CDR and SRM methods of geoengineering is. Essentially, I come from India where the lifeline of people, is determined by the monsoon and its behavior. So I'm not a geoengineering expert, to confess, but I'm watching the issue of geoengineering from the sidelines for a long time. And a genuine concern for the people living in that part of the world where, anything that we do to the nature, if it affects the performance of the monsoon, it is going to really impact billions of people. And from Ken's work and several others associated with him, it is very clear that anything that we do in terms of solar radiation management is going to impact the monsoons first, whether it is Asian monsoon or African monsoon. And largely, the tropical rainfall is going to be reduced, at least what the model simulations are showing. And recent works from the University of Reading also showed the solar irradiance reduction prescribed in the models which is used in the GeoMIP. They are underestimating the tropical rainfall reduction. But if you take a realistic sulfate aerosol kind of specifications in the model, the rainfall reduction is much larger. So I personally view this as a problem where we are not really reached a stage where, as Ken says, that there is no urgency of doing it. Every year, people around the world are watching the COP meetings, hoping that we hear some good news about some negotiations fruitful. But there is no serious commitment from the policymakers yet on the reduction of the greenhouse gas emissions. But in India, we believe that prevention is better than cure. So I think once we know that there are serious problems with the current emissions, I think it's rather nice to address that issue first and then demonstrate the seriousness and sincerity of the people to reduce the emissions. Only then we should really think about SRM or any other means of geoengineering as a possible alternative. And we have seen this happen time and again, when the global warming debate started, it was debated again, adaptation versus kind of mitigation. And now we know that most governments take the easy way of adaptation by investing some money, like putting shelters along the coastal lines where tropical cyclones form, But we know that that leads only to the complacency, that, there is a way out for in the short run. I think I view the SRM or any other techniques which are easily doable by any individual nation or by individuals is a means of diverting the attention right now, where people are looking forward to the kind kind of Paris COP meeting where they hope something will be done to address the mitigation as an issue. I think there are unknown and known consequences of this geoengineering to mostly to the tropical regions, and not that extratropical regions will escape from it, because we know ozone depletion could harm many people. So I feel that we should send out as a scientific community from this forum a message to the UNFCCC or UN to the extent based on the existing literature itself that these methods are still kind of very, very nascent stage, and that we should not let anyone unilaterally do anything, and there should be some moratorium on these experiments, whether it is the field experiments or indoor experiments. I think we should give the first priority to to push the agenda of emission reductions and convincing the policymakers, rather than giving them an opportunity to find a new excuse not to do anything. I think coming from that part of the world, we know the greenhouse gases itself are impacting the low-income people much more, and even this kind of remedial measures will impact the people, the same set of people. So I think, given that, I feel we should resist from really advancing this as an idea, as an alternative for mitigation. And I'm sure the other panelists will dwell upon this issue, and we can debate more with the interaction with the people in the next 40 minutes or 1 hour. Thank you so much.
Thanks very much. Mark.
So I'd like to add to the points that Ken and Krishna have already brought across with 3 points for you as a contribution to opening this discussion. Now, our moderator has already pointed out that geoengineering, or climate engineering as I tend to refer to it, is a very broad term. And Ken gave a nice introduction to the 2 classes, carbon dioxide removal and solar radiation management, or whichever names we'll take them under. What I'd like to point out first is that I think it's of great importance in the discussions around climate engineering that we distinguish very carefully between these 2. And this is due to the vast differences between carbon dioxide removal and solar radiation management techniques, so that the blanket statements that are sometimes applied when talking about climate engineering often only apply to one of these broad categories, and they can be very misleading or even counterproductive. The same point actually applies even to the subset of techniques within carbon dioxide removal and solar radiation measurement. As Ken pointed out, there's a vast difference between something like biochar production on the one hand and ocean fertilization on the other hand. Now, this point is well known by a lot of the research community, and it's mentioned repeatedly in discussions, and you find it in publications and assessments, but it's proving very difficult for us to actually follow our own good advice. And much of the community, including me, keeps falling into the trap of generalizing far too much. So I'd put it as a challenge, and I'd encourage more care and effort in making the distinctions clear, and we can try that starting right here in this great debate. The second point I'd like to make is about timescales. In addition to the points that were brought out about thoughts for and against possible deployment and what conditions possible deployment, I'd like to point out that if you take an assessment of the current state of knowledge for all of the proposed techniques to remove carbon dioxide from the atmosphere, at least for the ones that I'm aware of, you have to account for very long time scales, generally on decades with an S at the end, before you would have a significant impact from these techniques. Now, for a number of these techniques, this is due to the large infrastructure that would be needed. For some of them, it would be comparable to the size of the oil industry that you would have to build up, and associated with very large energy requirements. And for others, it's due to the limitations in ecosystems. So, and for many of those, there are also potentially significant side effects that need to be considered, and at the tail end, we have to consider what the uncertainties are in the total storage capacities. Nevertheless, though, as pointed out by my previous speakers, I would also agree that given the daunting consequences of the ever-increasing atmospheric carbon dioxide levels, it is worth continuing to investigate and to develop the potential for carbon dioxide removal. But it's important to make it clear that this is being done from a long-term perspective. We can't count on proposed carbon dioxide removal measures to notably supplement mitigation measures anytime in the near future. Now, the techniques to modify the Earth's radiation budget, the SRM techniques, if they were implemented, they could act much more quickly to cool the planet, actually on the timescale of a year. But as you probably well know, they harbor very large uncertainties about their effectiveness, about the varying regional distributions of their effects on temperature and precipitation, and about a palette of potential side effects. So even though it might be possible within a decade to develop and implement the technological capability to modify the Earth's radiation budget on a global scale, it would take decades to be able to do so in a knowledgeable and justified manner. And not only in terms of the physical consequences, but also in terms of the ethical implications and the challenges of international governance that would need to be addressed. And that brings me to my third point. We're holding a great debate about the issue of climate engineering at the EGU annual symposium. So we're talking amongst ourselves with geoscientists. We're the ones who know best how to investigate and understand the implications for the physical, chemical, and biological Earth system. But it's important that those who choose to address this issue in our scientific studies don't lose sight of the vast range of societal issues that are associated with both carbon dioxide removal and solar radiation management. And it's not only the possible future implementation that we have to be concerned about, it's even that there are ethical concerns associated with research and dialogue. I'd like to give a quick example of one of those. The most well-known among these is the so-called moral hazard, which is the risk that even giving the impression that a plan B is being worked on and might soon be available could end up reducing the motivation for implementing mitigation measures to reduce carbon dioxide emissions. Now, the verdict is still out on this and other concerns which need further empirical social research, but the concerns, should be noted, are very far-reaching. They extend all the way to our understanding of what it is to be us, of what it is to be humanity, of what humanity is and its role in the Anthropocene, an Anthropocene which could shift from largely unintentional and uncoordinated global impacts to a coordinated and intentional modification of the Earth system on a global scale.
When I started thinking about this debate, to which I'm glad I'm invited and I'm glad to be here, and I think it's a very important topic to discuss, well, in public and not in certain chambers of scientific institutes or private institutes, and I think the public debate is really crucial here. So the first question is, that came to my mind, should we try developing climate engineering? And there my current answer is certainly no, since we don't have any proof of concept, we don't have any clue whether any of these methods might work in the way we think it could work. The second question is, should we do research on it? And here I think yes, research is needed because climate engineering is on the table. It's in the political and the climate negotiations. We have this potential moral hazard situation that some people or some players use it to win time or money or delay things, have some certain political agenda behind us. And we as scientists, I think we have the responsibility to inform the debate, inform the public debate. In the end, society has to decide what we want to do. But scientists, the role of a scientist is here to provide useful information. And this is best done in a public debate and as publicly funded science. So that's one reason why in Germany we started as a bottom-up approach from scientists to initiate this priority program on assessment of climate engineering. And so it's funded by the National Research Foundation, tax-funded. The taxpayer can ask us, what do we do with our money? And we have the responsibility to explain this. And we have a public website, www.climateengineering.eu. So I have a few flyers here where every day we put a few, well, 2 to 3 to 4 new items in which everybody can see what is going on. And this is, I think, our responsibility, which I see is really important here. Assessment of this potential option. And so far, our science shows the closer we look, the smaller the potential becomes, both for carbon dioxide removal, which also has radiation side effects. If we plant forests, then the albedo changes and it might get warmer. So many very strange things can happen in the Earth system, in a coupled complex system. And the main problem is we have always winners and losers. I haven't seen any win-win situation where we have only winners. And so that's the crucial political point or societal point. How do we deal with this in a situation where we create new winners, new losers? And I think we don't have any good structure to deal with this. And this is the main task for political and social scientists to come up with an answer. Could we ever manage such an, well, even large-scale carbon dioxide removal initiatives? Could we handle that in a responsible way to redistribute wealth and winners and losers and compensate and minimize risks, political risk particularly? And so this is, I think, there are many aspects that we have to, well, research and we have to inform the public about in order to come to, well, better informed international climate negotiations. And so far, I think that I haven't seen the silver bullet that could save the world. And well, being in this research for a few years now, I think I'm become more and more depressed that, well, there's no good solution, and the opportunities, I think, become smaller and smaller the closer and more carefully we look. That's my current impression, but we have to publish this and we have to discuss this in public as we do here. And it's our responsibility to discuss this with you. Thanks.
So I believe in the Earth system, and so I believe that the climate system is only one part of it. So I believe that we have to engineer the whole of the Earth. And, you know, we may get a good climate for free if the whole system starts to function. And that may be too naive and too optimistic. I don't care. Right? I am an engineer, an Earth systems engineer, so I believe that we're going to change the system. But the difference between me and an Earth scientist is that we make a plan. You know, we're going to say, you need to do this. And most of our systems are collapsing. And some of them we don't even realize they're collapsing, but they are. So I work with it in landscapes, and we need all our food, we need our water, we need energy, we need a safe place to live and prosper. And the motto of our institute is enough for all forever. Okay? So what is a healthy system? Well, usually a healthy system has healthy subcomponents. So I would say we work with nature. Okay, so I believe in natural engineering. Okay, I don't even know what that concept is. Is it different to geoengineering? I just think we need to get this term geoengineering sorted. Okay, so we can get the scope. So it's not just a sci-fi story. It's a real part of changing the Earth. So the thing with natural engineering also admits that we can't go back to nature. Those systems have gone. Say goodbye. They've gone. We need to make a plan for what we think the system should look like in the future. So the things that we are geoengineers. We deforest, we create intense agriculture. I'm much less worried about urbanization, actually. So we manage the skin of the earth, we manage the soil. So once we start growing crops intensively in the soil, all the carbon disappears. We can still grow big crops and have big animals. We just have to add water and nutrients. So it ceased to be a soil, it's just a growing medium. So we must geoengineer. So you might say something obvious, well, let's put the soil back. It's too late. You know, we're probably going to have less soil and more intense agriculture. So we might have to think seriously about mitigating in our landscapes. So we need more forest, more wetlands, more ponds and lakes. So first experiment, let's go to the crop belt in the States and have 20% forest. There you go. Take that back to America with you. But another option is to have a lower intensity farming system. Okay, that also starts to help, and it starts to help carbon come back to the soil. And you know, basically, we would need more land then. So I would like to geoengineer, and I would like to green the deserts. But don't make any mistake. I already get potatoes from the Egyptian desert, and if I did like asparagus, I know that it would come from the Peruvian desert. Okay, so I do believe that we can geoengineer and bring water to these marginal lands and to the desert. Okay, I think that's the geoengineering we probably could do. But that's not the important question. It is, when we've brought the water to the land, what are we going to grow, how are we going to grow it, and why are we growing? Who are the winners and losers? Okay. Well, should we go further? Should we put enough water on the landscape so we bring back all the aquifers, the springs, and rivers? So we actually bring back new landscapes that we lost. Okay? So I'm more optimistic. Maybe I'm deluded. But I think there's a vision of the Earth. And there's a good point about timescales. I mean, a shift in philosophy can happen immediately if individuals start to behave better. I do have one big worry, and that is geopolitics. I think it was stressed as if individual countries act independently for their own purposes. So if there is to be geoengineering, it has to be global. Okay, the experiments need to be shared. They need to be visionary. They have to have good aspirations so that everybody benefits from the experience. Because from my own experience, once a farmer sees a good idea, they all take it up, and it's almost instantaneous. Okay, so the only thing that worries me is geopolitics. Thank you very much.
Thanks very much to our panel. Before we go out to the audience, I'm going to invite the panel just to briefly respond to the other panelists' introductions. So we'll go back along the table in the same order, but I'll just give you a couple of minutes each, okay?
There's a lot to talk about here. So let me just bring up one issue that I think hasn't really been touched on. And Dan Kahan has done some interesting social science research showing that climate science deniers are not persuaded by being introduced with additional facts about climate science. And one thing I have found in speaking to climate science deniers is that solar geoengineering is a very effective tool. Because when they say, oh, that climate scientists just make models to cook up whatever answer they want, and you say, well, look, I don't really like solar geoengineering, but the model says it would basically work, they start believing that the model means something. And then if they think, oh yeah, maybe we should do something on solar geoengineering, that causes them to acknowledge that there's some potential for climate catastrophe. And then when they start thinking about the problem more, they start realizing that continued greenhouse gas emissions with an ever-expanding layer of sulfate aerosols in the stratosphere has an ugly, ugly end game. And so they understand that, oh, we better start doing something about CO2 emissions and CO2 removal. And you know, I see some people in the audience laughing, but it's not a joke. I've seen right-wing climate science deniers come around to saying we need to transform our energy system into one that doesn't use the sky as a waste dump, where the entry path for this transition has been an attraction to solar geoengineering. And so maybe I'll just leave it there and let others comment.
Okay, thanks, Ken.
Actually, I just wanted to clarify that I'm not really saying that, you know, all the approaches for geoengineering should be completely kind of, you know, abandoned. In fact, Mark was highlighting the difference between CDR and SRM. I feel this debate is largely from this community is more on the solar radiation management and less probably on the CDR. I think CDR, if it is done in a very technically sound way and with the local implications, probably it has no large-scale global implications. But also we know that it is a very slow process to really see some results. But what is tempting is the fast reaction solar radiation management, which can impact the global climate in a very short time, like what we see in the volcanoes, isn't it? So, but the one point that I want to highlight here is the general tendency for the policymakers to be very complacent. I would give a simple example, which is not related to the climate. Like, you know that tuberculosis has been a major health hazard in many parts of the world. And when the new drugs were invented, the death rate has reduced. But if I see the way the governments operate in many countries, including probably India, that they think that now there is a drug to take care of this disease. Why do we worry about prevention? Like, so the number of cases of incidence of tuberculosis has not come down, even though the death rate has come down. So there is general tendency for the policymakers to take things easy when you show them some way out in a short term. So that is a point I'm trying to make here, that we are at a juncture where some negotiation should yield some results that people can see. Definitely there is a commitment, and we should wait until we see that the emissions have stabilized in the atmosphere, that we can think about advancing some kind of ejection kind of emergency exit button kind of scenarios. That's all I wanted to say.
Okay, I'd like to pick up on 2 points that are fairly related to each other. One from Ken, which I appreciated that you brought out the point about the potential of counteracting the impacts like massive famines with hundreds of millions dying. And if we get to a point where that were happening in the 4-degree world or beyond, and there were a relatively easy lever we could push by implementing some type of probably solar radiation management to get it going quickly enough, that it would then possibly make sense to do that. And what I often bring out is the point that there already are something of a few hundred million people who are malnourished around the world. And perhaps there are levers that are not much more difficult than actually doing solar radiation management well would be to push, since we have quite a lot to develop. So maybe we should actually turn that argument around, and I'm sure Ken agrees with me on this, and use that as an incentive to get going now. And the other point that I would bring out is with Paul's optimism and his thought about bringing the message back to my country of birth. And I'd point out another little message about my country of birth. I agree with your worry about geopolitics in that sense. And one of the big fads in that country is diet pills. And sometimes I wonder a little bit about the absurd relationship between something like solar radiation management or geoengineering on a broader sense and diet pills. And maybe this is, the diet pills help to, or there's an attempt to cover up a symptom of something that has a deeper cause to it, which is, in the case of our climate change, is our massive consumption patterns and our addiction to cheap energy. So if we were able to engineer effectively, perhaps it would then eventually reduce the incentives to really be working on the transitions that we need for a long-term sustainability. And that's exactly the politics. It's more the politics than the geoengineering. So I agree with you thoroughly. That's where we need to be concerned about.
I have 2 points as well. So first, it has been said, or it's pretty often said, carbon dioxide removal has not necessarily big side effects. I think that's not true if we really want to have a major dent in the CO2 concentration of the atmosphere. If we want to remove a major portion of our current, or compensate for a major portion of our current emissions, we have to modify the Earth system by a huge amount. Just afforestation of the Saharan desert and Australian outback compensates for about 10% of our current emissions. And that changes climate. We change the albedo, we change rainfall patterns, we create new losers in the system, and it will have side effects. And right now there's no way that we can forbid Australia to plant forests in the desert, and nobody will do it right now, but there's some governance problem already with CDR, and it will have side effects. Or fertilizing the ocean, putting alkalinity into the ocean, and large-scale operations would have global side effects. And so I think the distinction might be smaller than it sometimes appears between solar radiation management and carbon dioxide removal. Greening the Sahara to grow food, I think would be a different motivation, a different aim. That's planetary engineering as well. But there if things go wrong there, that's like manslaughter. If things go wrong, if we want to modify the climate, that would be murder. I think that's also the moral difference. The result would be the same for many people. But the implication is different, and probably the legal and political governance issues are different as well. So I think that's why we've put climate engineering, really the emphasis of that is modifying the climate and reducing anthropogenic climate change.
Yeah, I think the first thing I'd say is in the landscapes I work, there's so many win-wins. Most of the answers are so obvious. So to grow a certain crop that feeds a large number of people that's low in water consumption, and then you burn the biomass waste, it seems like a no-brainer to me. So that if we need people to function on that level as individuals and small communities, so that the smallest social system is functioning correctly. And that's the way we spread the news. If you say that can't happen, then we have to go to the sci-fi methods, okay? And I don't want to afforest the deserts. What I want to do is do experiments on the edge of the desert to see if it's worth doing, to see whether it's worth going across there, okay? So we do need controls. But I do think some really obvious things with how we used to live on the Earth can be accounted for. We can mitigate for overproduction. We can bring things back into the system, work with natural processes. So I do believe there's a lot of win-wins, which are more about us, the community. We've got to operate better. We've got to not just change our diet. Brad Allenby, who invented Earth Systems Engineering, says the people who are going to live to 150 years old, they've already been born. This is why the system is so desperately in need of geoengineering. But I still worried about the scope that we see it as just the management of carbon levels. Okay, I do think it's more about how we manage the Earth, and we need to link them all through the Earth system. So we need to think big, but we need underlying messages. So work with nature. Not go back to nature, but try and at least get back to the carrying capacity of the land. We can probably feed everybody. I'm not worried about that. We can all live in megacities. I'm not worried about that. These are the big changes, but they're probably good things. We can feed a lot of people in cities. We can feed a lot of people, give them good health and a safe place to prosper. So in a way, I'm really quite optimistic, but it does require us to think much more broadly about geoengineering. So I'm a bit worried that it's only about climate engineering. So I'd like to join it to the Earth system.
Okay, thanks very much. I'd like to thank our panel again before we go out to you. So, I'm sure you agree, lots of thought-provoking stuff there. What I'd like to do now is to start taking some questions and points from the audience. I have two lovely assistants down here who have got roving microphones. And so what I'll do, if you'd like to raise your hand, if you'd like to ask a question, what I'll do is I'll take several questions and points at a time, and then bring the panel back in intermittently, okay? So if anyone has any questions or points they'd like to make, if you'd like to raise your hand, and I'll... Have we really bamboozled you that much? John, do you want to get over here? Mark, right at the back there, if you could take that mic back there. And keep, if stuff comes up, sorry, but when, then raise your hand, because I'm going to keep an eye and keep the microphone moving around the room, okay?
Okay, Mayor. About solar radiation management, maybe we even need to research into countermeasures, because what if someone need not be a country, it might be a multinational, maybe Google, wants to save the world and just goes ahead and does it. So shouldn't we research into countermeasures?
Okay, thank you. And that at the back.
My question is about solar radiation management and the potential of increasing the reactive surface area of the stratosphere and the potential to dramatically reduce the ozone layer. So I'd like the panel to comment on that.
Okay, thank you. Any other questions at this point? Down here, John, do you want to get down here? You're nearest. Are there any others at the moment? Because then we can move the mic. Well, yeah, Mark over here, please.
Yeah, to stay on the same topic, should we consider it as problematic to do solar radiation management research, as it may prepare the ground, the knowledge for something like environmental warfare, or doing something with malicious intent that should hit certain regions of the globe?
Okay, thank you. Yeah, indeed.
Paul Quinn talked about greening the desert. So are there any large-scale experiments, and what are probably the biggest problems? So is it mostly the albedo effects or something differently? Thanks.
Okay, thank you. Right at the back there, Jonathan. See, can I have you running up and down? This is one of the reasons why I say if you put your hands up now, I can actually move the microphones in the meantime.
We had a great lecture yesterday by Andrew Watson, who showed the evolution of the Earth and these major revolutions. And it just stopped with the present where it got interesting. But he gave some examples from the past where the system made these big steps by big catastrophes like glaciation, and they might have links to things like transitions from, well, towards altruism. So I wonder about, when you talk about millions of people dying, are we able to engineer a better system now, or will we face a similar change like Earth did before, where we need to go through catastrophes to come to a new system which works better in a more collaborative way.
Okay, thank you. Anyone else? Yeah, there's one here. If there's anyone else who wants to raise their hand now, I can get, right, can we have a microphone down here as well, please?
I've been reading recently about the effects of land use change, and I agree that perhaps this should be part of the geoengineering debate and actually the wider climate change debate, because it's talking, been reading about how land use actually has quite a large effect, and so specific examples, southern Florida, when they drained all the swamps and wetlands, the climate sort of changed, the summer and winter extremes changed by several degrees, which is large regionally, but you don't see this much in sort of global climate change measures like the global average temperature, because it's a small area and the summers got hotter and the winters got colder, so the annual average wasn't very different. But if you think in terms of the effect of climate on humans, the things that matter are the climates where we're growing food and the climates where we live. So, for example, the urban heat island effect is actually, although when we make up our measures of global annual temperature, we take out the urban heat island effect, but actually it has a big impact on people. You know, the European heat wave in 2003, which killed tens of thousands of people, that's one of, in terms of loss of life, that is one of the most devastating weather events. And so perhaps we should be thinking more about again, engineering the whole Earth system and the places where we live, the places where we grow crops, and so forth, to, even if the global climate is getting warmer, we may be able to make the cities where more than 50% of the Earth's population live, we may be able to make them, better for humans. And similarly, if you have if you retain some sort of natural forests and stuff where you grow crops, then you may be able to reduce the climate changes there. So I guess this is a general question of whether you think this ought to be part of the geoengineering debate, and indeed more generally the climate change debate, whether we need to think more locally about protecting climate locally, I guess.
Okay, thank you. Mark, there was someone over here, and there's another hand over there. Okay.
Well, yeah, I'm a planetary scientist. I deal with very bad case. Venus too hot, Mars too cool. And the Earth is very magnificent, but temperature going up. I think we know all the reason. We are consuming CO2 because we consume a little bit of each CO2, each of us, and the number of people is increasing. A few years ago, we were going to say that we are going to culminate to 9 billion in 2050. Now we think it is going to be over that. Clearly, the problem of climate change and many other problems are linked to this number. 9 billion people, maybe 10 billion people. So we are considering alternatives like geoengineering, and most of you have said, well, geoengineering is very difficult, if not impossible. So maybe it should be our responsibility, we scientists, to say, well, don't put any hope in geoengineering. It will not going to work. You have to mitigate the problem by another way, by saying that we have to stop growing the population. And I think it is not the geopolitics we are going to go and say this message to the public. Maybe the scientists must give this message to the whole world.
Okay. Green mic.
Is it on? Yeah, okay, thank you. So a lot of the research right now is focused on this solar radiation management by putting sulfate into the stratosphere. That's one of the popular things. And the research that's being done on this focuses largely on these GeoMIP models, which represent perturbations on a mean state of the stratosphere. And the uncertainties in the perturbation are heaped upon the uncertainties in the basic state, which is not that well understood. So to put this concisely, I'm wondering what the balance ought to be in this research between studying the geoengineering and studying the, in other words, geoscience rather than geoengineering, just to understand the basic state first.
Okay, thank you. Could you pass it along to, there was a guy just there.
Hi. So this idea of moral hazard has been brought up a few times. So I guess my question to the panelists is, do they think political inertia on mitigation could actually get worse?
Okay, thank you. I think we'll come back to the panel now. I'll come back out after I've asked the panel to respond to those, but there's quite a few thoughts there for them to respond to. So Ken, would you care to respond first?
Well, yeah, right. There was many very good. Let me just take a few of them and I'll pass it down. So on countermeasures, I think most people think that the countermeasures, you know, if some rogue actor were deploying it by themselves, you could freeze their bank accounts, you could bomb them, you could arrest them and jail them. So I don't think the countermeasures is putting some other kind of aerosol that would cool the earth. Ozone, I mean, after Mount Pinatubo, I think it was a global several % loss in ozone. It was more in the northern high latitude spring. And so I think the issue is, you know, are things bad enough so that you're willing to have a little more ground level UV and counteract it with something else. And so let me also, before handing the mic on, just comment on something that was, I guess, Andreas Ashley's asserted several times, and that is that the idea that there'll be winners and losers from a solar geoengineering deployment. And I basically don't believe that's true. I think if we look at the subprime mortgage financial crisis of 2008, I think something like 10 to the -6th of the people on this planet benefited from that and became rich, bankers, investment people. And almost everybody else, there was a 5% decline in GDP, almost everybody else suffered. That I think if the Earth is really in a crisis with widespread famines, the global economy is going to be devastated, that either it's going to basically work and basically make everybody be better off, except maybe 10 to the -6th of the people, or it's basically not going to work and everybody's going to be worse off. I think this winners and losers is a meme that isn't really grounded in any kind of real analysis.
Actually, I will leave the several questions to the other panelists, but again, the countermeasures is something that came up here. In fact, I was making in my opening statement that given the evidence that we have, at least, you know, we should not let anybody take into their hands of like, you know, doing something unilaterally. I think, I do not know, like, you know, whether we are at a time when we can send a message to the concerned UN bodies that, you know, there should be some restrictions on who will do what they will do and stuff like that. Of course, Mark also alluded on those issues. I think that is a good thing. But again, I agree with the gentleman in the front that, as I told, prevention is better than cure. Like, you know, I think we have to, right now we have to just concentrate more on how do we mitigate than to say that, you know, we are going to avoid some disasters in the future, that we should start thinking in these lines. So I'm not against any science per se, but I think I'm only worried about the lethargy in the system in different parts of the world, that, you know, they don't want to do anything when there is any apparently easy option to kind of stall the things. So that's the thing that I'm really concerned about.
Okay, thank you. Just before I hand over, I just really wanted to pick up on the big contrast between some people who have got this very human-centered view, like this thing about the cities, versus the actually the message should be we should cut population. See if anyone would care to comment on that.
Well, I can comment on that exactly because I counted. And out of the 9 questions that were posed, 6.5 of those were focused more on social science. One of them was sort of halfway in between. So, and that's really interesting coming from the European Geophysical Union, or Geoscience, excuse me, European Science Union, boy oh boy. You can tell I'm a physicist, I'll admit. Coming from the European Geoscience Union, that we would have that much of an interest. And what I would say that certainly should encourage a very close interdisciplinary interactions between us as geoscientists and between social scientists. And a number of us are doing that in our programs, like the German priority program that Andreas Oschlies is heading. So I'll answer two of the physical science questions first, since those are the easier ones. One of them was about ozone reductions, and there, of course, the verdict is still out, as it always is in any kind of Earth system science, but there have been a few papers published so far that show that with the level of stratospheric sulfate injections that we would need in order to cool the Earth by the order of a degree or a few degrees, the order of ozone reductions is around 10%, and actually you get a slight increase in the amount of ozone in the tropics due to inverse chemistry interactions. So that's probably not, at least based on our current knowledge, going to lead to a drastic reduction in ozone. On the other hand, we would have said that CFCs, based on our current knowledge in the 1950s, wouldn't have led to a drastic reduction in ozone. So the verdict is out on that one. Regarding the balance of research with GeoMIP versus, so GeoMIP is a project looking at the climate model intercomparison simulations that were done for the IPCC, and then adding on climate engineering, or very specifically adding on either sun shield solar reduction or stratospheric aerosol injection solar reduction, and now they're looking at cloud brightening experiments along with that. And I'd say the balance there, to me, seems about appropriate. It's probably of the order of 1% of the overall climate research, or slightly less, that's going into climate engineering research. And going much beyond that probably doesn't make sense. But given the breadth of discussion and given the interest in understanding the social implications, for which we need to understand about the physical implications first, it makes sense to have some small order of research going on. And then the two that I would address from the social science side about countermeasures and environmental warfare, those are very closely related, and I can simply say that this is a hot topic. There are people from a broad range of political sciences, also from the military of several countries, are looking into scenarios about what kinds of implications this has, but it's too early on to say that there's any kind of verdict out of this. The one clear message that I seem to be hearing from a lot of political scientists is that it's because there would be a likelihood of retaliation measures, not physical retaliation measures as countermeasures, but rather sanction measures that would be applied against any country that tries to do it alone. It's very unlikely that sole actors would go at it. But we've seen many cases where even if there's a lot of sanction measures, sole actions do happen internationally. And about the moral hazard, the verdict is still very much out about whether or not the moral hazard applies. The one message that seems to be coming out in the literature from that is that it seems to be very regionally dependent, which I think would make sense. It depends very much on your basic social attitudes, whether or not then the discussion around climate engineering measures would reduce or not impact or perhaps even increase your incentives to get going on mitigation.
Right. I think most questions have already been addressed. I'm just trying to focus on three. The population growth argument. I think right now most of our emissions we have in the air so far have been emitted by 1 billion people about, and so that's already quite a lot of CO2 by quite a few people. And we can't, just by controlling population growth, reduce CO2 levels. So, and I don't think anybody would like to suggest reduction of population. So I don't think that would help us to really solve the problem. And the same applies to these local measures, like changing the climate or improving the climate in cities and having these win-win situations where we grow crop and use the waste products. This, in a continuing high emission world in which we are right now, this does not have a significant impact. And since we emit so much CO2, you see the Keeling curve and the annual, the wiggles there, that's the seasonal cycle. That's the planet turning green every northern hemispheric summer. And this is just a small noise on this rapid increase. And so that's the magnitude of the problem. Many, many seasonal cycles that we have added to the atmospheric CO2 concentration. So I think these local measures are fine, or win-win, mostly, or manslaughter maybe, but I think nobody would argue with those. And here we have to argue about really engineering the global climate and making a significant change in a high-emission world in which we are. And I don't think that's well, the question was, should we act right now before we have 100 million people starving? But we can't act right now. We have this precautionary principle. We can't act if we don't understand the consequences. And we can't even act if we have a single loser. And that's, I think we can probably argue the average will win, but that's not enough. Like vaccination and medicine, we can't have compulsory vaccination if there's a single, so the individual has, at least in most countries, or in many countries, we have put a very high value on the individual, and each parent can decide whether their kids are vaccinated or not, because there's a risk and kids may die, and so it can't be made, or it's very difficult to make it compulsory. And right now, I think it's, in many countries it's not. And so a single loser really, well, can stop action, and with some moral or ethical principles, that's the right way to stop action there. And right now we don't have the governance to say it's enough if the average wins. So I think that would, well, require a very different government or world governance structure, which we don't have right now, and which well, maybe we want it, but that's a societal problem, and society will have to decide, do we want to have the average population benefit, or do we have to value each individual? And right now we are not there, and so we can't engage into climate engineering right now, I think.
Just a quick comment on local fluxes. We're talking about local fluxes over 100% of the Earth. So it's local actions, but everywhere. And I do think there are, even though one tree only absorbs a small amount of carbon, we're talking about technologies that will help us absorb a lot more carbon. So we have peatland accumulation, locking up carbon in soil, locking up carbon in sediments. There's things that we can do, but they're just little tweaks to the systems that we've already got. So I am more optimistic. In terms of, have we done any experiments for greening the world? Well, that experiment started 4,500 years ago in the first geoengineering experiment, when the Sahara was still green, and then the small change in climate drove everybody to the Nile, and that's where they set up and did their first land and water management plan. So I do think we are geoengineers, and we need to look at these trends and see that we can offset most of them, I think. I know that there's a bit left. So when we come back to these experiments, I think we need to learn together how to do the experiments. So we need to do big experiments, and when we start doing them, we do them over quite large areas, maybe with coastal and some ocean, some atmosphere above, and everybody attends. That's the social scientists, the economists, and a range of geosciences, so that we can just get used to doing it together, and then eventually we might say, well, actually, this is good. I think we can roll this out across other things. So we need to learn together. We need to get our geosciences sorted. In terms of the catastrophe and the 10 billion, I'm just not worried by that. In fact, when we get to 10 billion and the population stops growing, we should celebrate. We can sustain and feed everybody on the Earth, and there is enough water for everybody. It's just, we need a really good plan. So I'm much more optimistic. We shouldn't be too fearful about having 10 billion. We can cope. So just one more point about, do we need the catastrophe in order to get us going? Well, we do have concepts in Earth Systems Engineering about how we force our systems. And one of the things that we seem to find out, and I think China's a good example of this, is they always go right to the edge and then suddenly come up with a solution. So there is that kind of, we start to be alerted by all the problems, like increased floods and droughts and people having famine and poor health. And then we start to put the system, so that we don't want system collapse, but I'm not worried about considering forcing the system until we actually correct the system.
Okay, I think I'd like to go back out to the audience now. So, have we got any additional questions and points if people would like to raise their hands? We've got one here. Jonathan, do you want to start down here? Anyone else? There's one back there. Mark, do you want to get that? Is there anyone else at the moment? Okay, so we'll pass along to you next then. Okay. The yellow mic, please.
Testing. There we go. Right. I'm going to sort of start off by saying what I'm going to say is from the viewpoint that I am pro-geoengineering research and potentially pro-geoengineering. But I think Geoengineering research is already going on. I think the Earth offers us an excellent natural laboratory to study the potential effects of geoengineering anyway. So cloud brightening by cloud seeding is a study we've done in a natural laboratory in the Southeast Pacific. Volcanic eruptions allow us a natural laboratory for studying solar radiation management. So I think we can do those things without actively interfering in the climate. So back to whether or not we should do sort of geoengineering from my point of view. So we go from being a species that is indirectly interfering in climate through emissions to being somebody who's really taking control of the system and defining the system. So for the first time, we're going to define the system. Once you've done that, there's no going back. You've taken control. And you've set that system as it should be for the world. You've defined who those winners and losers are forever. And then you can have arguments in specific countries saying, we want more rainfall, we're trying to change this little bit. Where does that stop? And which parts of the system are we not allowed to interfere in? So we've talked about population growth quickly there, gentleman at the front. Why is that part of the system that we shouldn't be thinking of? And that's part of the change. You know, some of the predictions on the fact that population is going to level off are based on some very unsound ideas. You know, and the only way the population can level off is if you have equality around the world, empowerment of women, etc. But for that to happen, you've got to have a rising middle class. That rising middle class are going to want to consume more and consume at the levels of that 1 billion in the Western world that you've already mentioned. So I'm not convinced that we can ignore that part of the equation. So it's consumption per capita, but there's the per capita element of that. So thank you.
Okay, thank you. And then the person with the mic who's back there, yeah.
I was wondering...
Could you pass that mic along?
I was wondering, in terms of bang for the buck, if there's just some way that maybe, well, do you guys think there's any trying to generate new, better ideas for geoengineering where the risks are reduced would be a good way to spend money?
Okay, thank you. Is there anyone else? Because I'll get the mic moving while we've got any at the moment. There's this person here then. Yeah.
So I'm generally against climate engineering or geoengineering, but I'd like to point out or ask a question, when would we actually implement this, if possible? And I think we need to consider tipping points in the climate system, especially tipping points which are irreversible. For example, if the Greenland ice caps go, or Antarctica, part of that with massive sea level rise, we don't know how close we are to that, but if we knew how close we are to the edge of the table, maybe then we'd have to use these methods to quickly try to save the climate. But until we get there, I think it's a bad idea.
Okay, thank you. There.
Yeah, hello. Yeah. Two things about two legal issues, basically. The first one is I don't think we should allow that the integrity of individuals are protected by the UN and the people's rights. So we cannot say that anyone should be sacrificed for the greater good on the average. I think this will never be accepted. So I don't think that this will happen. My second question or comment, or would you think that somewhere in the future someone could get a verdict for ecocide, where they actually, one of the main...
They could get what? Sorry,
ecocide, like it could be judged for polluting, and you could actually get a verdict against you, like you do for homicide or I mean this. Is ecocide like in Hague, like something that we could make for the future?
Yeah. Okay, thank you. We've got one back here. Yeah, there's a hand. Yeah. And is there anyone who I could get this mic to?
Okay. Often the problem seems to be that we don't have enough knowledge of the side effects of the geoengineering, what we are doing. So I would like to ask the panel, from these methods what we talk, is this lack of knowledge of things which we known what we don't know, or do you think that it's more of things which we don't even know yet?
Okay, thank you. And the person with the mic here, where was it? I've lost it. Oh. There's this one over here. I thought there was a hand. No? Anyone else before I come back to the panel? Okay.
So there were several questions about research. There was one from the first round of questions that went unaddressed, then your question, also this unknown unknowns question. And I'll address this to the geoscientists. I think in in terms of, let's say, the latest IPCC report suggested that biomass energy with carbon capture and storage could become important to achieve low CO2 concentrations later this century. And for something like that, where you're working on an engineering system that makes sense to have an organization that's focused, where people are working full-time on this one thing. But I think we, as geoscientists, when we're coming to the solar geoengineering question, I'm going to put the carbon dioxide removal aside. When you come to the solar geoengineering question, I think it's really important not to have specialists who just study geoengineering. I think it's really important that the scope of science just gets expanded. So if you're somebody who studies volcanic eruptions and effects of aerosols on the stratosphere, maybe you would expand your scope to say, well, what if that aerosol population was extended in time? Or maybe it gives a greater emphasis to be ready to study, to observe the next Pinatubo and take advantage of natural analogs. And because I think if you create organizations that are focused on solar geoengineering research, you give incentive to say, oh yeah, we need to keep pursuing this angle. But if it's just a minor part of what is done across a broad community, then I think this scientific integrity will make sure that the real truth and facts about the situation come to the fore. So I would just plea that we sort of expand the scope as what we do as geoscientists, and not form cadres of geoengineering researchers.
Thank you. If we could just keep it to about a minute each so that we can get back out. Do you not want to?
Actually, again, there is a question about when is the time, have we reached the situation where tipping points are possible to do something to avoid major disasters? In fact, I was just thinking in my mind that, at least based on the publications that Ken is involved and others are involved, even if what we do has an implication for the food productivity in many tropical regions, forget about the tipping points. I think if you kind of alter the productivity by 10 to 15% in countries like Asia, for example, where more than 2 billion people live, we have already seen that solar dimming has been shown to be linked to reduced productivity of rice yields, at least, coupled with, of course, GHG emissions. In this solar radiation management, particularly as Ken says, we are only going to alter the daytime temperatures. Nighttime temperatures are not going to be affected much. So they have shown that both increasing temperatures in the night due to greenhouse gases and the solar dimming due to already existing aerosol clouds have reduced the rice yields in major parts of East and Southeast Asia, South Asia as well. So imagine if we kind of reduce the productivity in those regions by 10% with the increasing population at that rate. I think in 20, 30 years, we'll reach a stage where the food security becomes a serious issue within that region, forget about globally. So I think anticipating some unexpected tipping points, if we do something that affects the current situations, I think we have to be really very, very careful. That's what I want to say.
Thank you.
Okay, this time we're 3.5 from 5 for the social science versus the natural science questions. The half one being the bang for the buck question, because it's partly a natural science question of could we find something that would be more effective, but it's partly also a question of the value of finding something more that would be more effective. So the tipping points question was addressed by Krishna, and the known unknowns by Ken. I'm going to address the other three quickly if I can manage to. And first off, the first two I would link together. The question about the governance versus the trade-offs and the bang for the buck question. I think we probably could possibly find, if the research were intense, techniques that would be more effective, but the question would then be, how do we go about governing those? Even if they work, it's this whole issue of dealing with the trade-offs that Andreas and others have brought out. And the other one about the possibility of ecocide, international courts, I would point out there that there is already some bit of precedent for that in the Convention on Biodiversity and the London Convention and London Protocol, the Rule of the Sea, where they consider environmental impact assessments and the impacts that we would have on the environment as an entity in itself. But it doesn't quite go as far as ecocide, so that's still an open question.
Thanks. Maybe just adding for the bang for the buck question, the deployment costs seem very, very cheap, very small for many methods. But the real costs probably are, or the majority of the costs are really compensation costs. So how do you compensate the losers again? And that's will be a political bargain game, and that could be the major part of the costs really. And that's very difficult to assess, as it is in climate negotiations today already. So that's active research trying to assess that better. This economical, well, international. Trading assurance system, and that involves attribution and well, yeah, the entire attribution problem. Why is the monsoon shifting? Because of climate engineering? Is it just a natural phenomenon, anomaly? And all these things will have to be dealt, well, based on models in the end. Since we don't have the ground truth, that will be lost once we started climate engineering. And so we have only one planet, and that's then engineered. And so we have lost our natural system. And so it's very difficult to attribute causes and effects, and it's very difficult maybe even to identify effects, and we can't do any field experiments that are large enough to be detectable unless we already have a high risk messing up the planet. And so there's a real problem having to rely on model results only. And that's, sorry, okay, stop.
Okay, first of all, just to reiterate, I'm not worried about the per capita consumption. My 10 billion is 10 billion middle-class people all eating meat and drinking coffee, or even beer. Oh, that could just be me. But I think the urgency is we just cannot wait. We need some big experiments. Maybe we should call them living laboratories or laboratories for life, but they need to take place across the world. And they need to be open to the sense that everybody is invited so that we can all put something into the system and all get something from the system. That's a healthy system.
Okay, thanks. What I'd like to do is just if there are any last brief questions or comments, I'll take them now, and then we'll just bring the panel in for the last time. So we've got a couple over here. We've got one here. So yeah, if we could get one mic there and one there, and then we'll come down here. The yellow mic first, please.
Yep.
Yeah.
I don't think it's 10 billion middle class. If you talk to demographers, what they're waiting for, especially in sub-Saharan Africa, is the second phase of the demographic transition. The first phase is when you have the mortality decline, and the second phase hasn't happened there. And that's not making everyone middle class. That would be basically education for women, and women having basically some self-determination. And they won't be middle class, but it'll be a huge difference. The country I study, Burkina Faso, has 6 times as many people as it did 80 years ago. It's a monstrous problem, and they wouldn't be surviving if it wasn't for huge cities like Lagos and Dakar taking up all the extra ones. So they are on the edge.
Okay, thank you. And can we have the yellow mic down here, please?
So I think a lot of the debate now has been on a top-down approach to climate change and geoengineering. But I think if you look at like large changes in human history, it's like a small event or small invention which has like exploded and then changed the whole course of, well, basically everything. So I would like to know your ideas on what kind of those small innovations, for example, in solar energy or in personal energy use, in eating patterns could actually counter climate change.
Okay, thank you. Before I take this question, is there anyone else who can get that mic too? And down here. Okay.
Yes, thanks. Could there be some consensus or some statement on some of these techniques, SRM or CDR, where we can know that and state that it's not a good idea, that we know already that it's not a good idea? I'm thinking particularly at iron fertilization, because it's not, we are not talking about side effect there. It's just we change the whole ecosystem. We know that technically it's almost not achievable globally to have a significant effect. I'm thinking also maybe at mirror in the space, which looks crazy. I don't know. So is there what do you think? Is there some technique that we could have a statement on, saying, no, this one we can already give up, it's not a good idea, or we should still continue to study all of this one?
Okay, thank you. And there's this question. Yeah.
I just want to open the debate up and just ask about mass migration, because you could say there are parts of the globe that are currently not populated. If the Arctic warms, there's a whole land area there that might be accessible. So linking that also to about how we manage, you say where there are regions that could be impacted more or less, how do we kind of put some resilience or guarantee that we don't mess the system up so much that we can't actually use some of these potential areas?
Okay, thank you. And I can take probably just one or two quick last points. It's going to be a last opportunity, right at the back there. Is that it? Oh, there's one over here, right, and that will be the last one, right back there.
Okay, this is probably rather a comment. I find it very interesting because we're touching a point where we ask if we may research everything that we can research. And when answering this question, I think we have to consider people's interests, which is very difficult here because we are dealing with a common good, which is the Earth. And I've heard you talking a lot about risks. To my understanding, a risk is something that you can calculate from its probability and the costs. But I think in the case of geoengineering, we probably are rather dealing with an uncertainty. And I'm not sure if it is ethically correct to gamble.
Okay, thank you.
Yeah, my question was actually also on uncertainties, given that even in the CMIP5 projections, there is a great deal of uncertainty on the evolution of the climate. I was wondering if the GeoMIP experiments had shown an additional layer of uncertainty in the possible impacts that these different techniques could have, and that given if these uncertainties are so big, shouldn't we be focusing more on climate services, for instance, to give more, I'd say, realistic solutions for people to adapt to climate change? Thank you.
Okay, thank you. And now I think I'm just going to ask you just to do about a minute each, because we're going to do a vote. I'm not quite sure what on, but we'll do it at the very end. Okay.
So there were many excellent questions and comments here, and I just can't address them all, so I'm going to say something that I want to say. And that is, I think there's a fundamental issue here of what is our vision of the future we want to work towards. And I think Paul kind of presented one vision in which we manage the Earth and maybe we act as stewards, but basically we're controlling the Earth for our own purposes. And the other perspective is where we try to walk as lightly on this planet as possible and interfere with natural systems as little as possible. And I have to say that I fall strongly in that second camp, just because I feel the Earth system is so complicated that any interventions we do are likely to screw things up, and that also there's this issue of irreversibility, that the more lightly we walk on this planet, the better the chances that we'll hand it to future generations in some condition, and maybe even better than the condition that we got it in. But I think this fundamental view of is the Earth something that we control or something that we try not to control? And I feel strongly that the latter is the better path.
Yeah, I really appreciate the in fact, I really appreciate the last question from that corner about the uncertainties in the models. In fact, if you take the SIMI-5 kind of situation where the radiative forcing is slow, and we know by middle of the century, end of the century, this is likely to happen, that is likely to happen, at least there is a chance for error which we can adapt to. But in the case of this one, the experiments that we conduct using the models, I think accuracy of the models of the SRM evaluation should be much, much higher than the SIMI-5 type of models, because the response is going to be much faster. We cannot wait for 50 years to see what is going to happen. Now, if you do anything with this kind of a tinkering with the nature, next 4 or 5 years we might see the consequences. Then if you don't know what they are going to be clearly, then we are really getting into a kind of area where there is a lot of uncertainty, like the lady standing there rightly said, that we are really playing with the nature. So I think personally I am, like as Ken says, the second part of it, I am very much against this kind of an approach right now. Particularly the timing of this is not right, because we want to see how the nations would react and come up with some solution for mitigation seriously. And then probably down the road we can think about this as an alternative for any kind of tipping point kind of avoidance, like what other gentleman mentioned. Right now I think we should concentrate more on energy efficient technologies and mitigation options. Thank you.
Thank you.
So I didn't count this time, but I'll hit the easy questions first too quickly. Can we rule out any of the techniques? That's a disagreement in the community. There have been papers published that say time to move on, whereas others continue to study the topics. So it's still very open. The uncertainties in GeoMIP versus CMIP, see me afterwards. That would take much longer than the time that I have to explain, and it's quite interesting. And the last one that I'd like to bring out is that in a broader general statement about the question, may we research everything that we can research? The may question, and about the difference between risks and uncertainties, which is very much a physical and social question. And I think in researching this topic, we need to recognize the responsibility that we have. This is what I tried to bring out in the opening statement. And part of recognizing that responsibility is to make a great effort to bridge expertise. We've had a lot of questions about social sciences, about law, about ethics, and I think one recommendation that I would put out is that the EGU make the effort to bring social scientists and philosophers and law researchers into the debate, into the discourse with our physical and chemical and biological scientists, so that we can really lean on the expertise rather than having a bunch of natural scientists up here telling you what we've learned from our colleagues, so that you can really get the picture appropriately. And I think that will be an important part of our responsibility in recognizing this is a very, very controversial and ethically questionable issue, even to be doing research on.
There was a good point about these small innovations that may always come around tomorrow or today. And I think that's our general optimism that drives us. And well, of course, and that seems to drive Paul a lot. and so I think that's what we have to hope for, that something comes up. And we haven't identified it right now. That's also why we need research and clever people and young scientists getting into this societal problem. The global climate engineering, I'm glad we are not living in a completely engineered world. I would ask, who would be in charge? Whom can I blame if it rains too much, if I have flooding or drought? And right now I'm happy it's nature. But once somebody is to blame, people will be unhappy, I'm pretty sure. People will always fight, and that's not very good. I can't imagine that going down well. But that's the governance problem. If somebody has to be in charge, we have to control that to make people happy and to make all the losers and every single loser happy, I think, compensate. And that's, to me, unreachable right now.
I agree. We need a vision, and the vision needs philosophy. So there might be lots of scientists here, but really we just need to get our philosophy sorted. When people refer to risk, we are already gambling. So don't think, are we going to take a risk? Are we gambling? We are already gambling, okay? So some parts of the philosophy that we're looking at is that there are no guarantees, okay? Can we get used to that? We may end up having to mitigate for our mitigation, okay? And then mitigating for the side effect of the third mitigation, you know. And then we've got this other concept, which is no regrets, which is we push forward even though we're not quite sure of the science and we're not quite sure of the consequences. So I really do agree with Ken that we must walk lightly. That's the best thing. I can really, really go for that. But we must walk lightly on the system. The system's going to contain megacities, intense food production zones, maybe mitigation zones. But I have a vision of beautiful green megacities with urban agriculture and a beautiful place to live. So again, I am an optimist.
Okay, well, thanks to all of you, and thanks to our panel. Before we go, we said we'd have a vote. There's such a big area that what I'm going to say is what we'll vote on is, should we do some big experiments now? So if you think yes, put your hand up. Well, we've got to keep it general. It's too big a subject. Oh, there's not that very many. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. That's about 30, I think. No, and then no. Yeah, go on, let's see no. Oh, it's definitely more. I think no wins. Okay, thanks to everyone. Can we thank our panel again, and thanks to you for taking part.